Hello everyone. Today we'll find the distance of closest approach. So first of all, you should know the what is closest distance of closest approach. So that is the minimum distance up to which an energetic alpha particle traveling directly towards a nucleus can move before coming to rest and then retracing its path is known as distance of approach. So this is we are taking at the new this is the nucleus, and the distance between the alpha particle is incident, and this is the impact parameter, which is the b, and this is the with it striking with the initial velocity, and this is called the distance of approach. Okay, from the center to the point, and this is ZD, which is the charge. Okay, so from this we'll find the distance of closest approach. So let's go. So distance of closest approach, so we should know the force, and the electrostatic force is 1 by 4 pi absolute naught. So here is a Q1 and Q2, both are identical. So instead of Q1 and Q2, we can write ZE, that is atomic number, and electron. So here is also the same, by R square. It is the Coulomb force. It is none other than the Coulomb force, which is the electrostatic. Okay, electrostatic force. So we know that work done is equal to the potential into charge. Okay, so it is a 10th grade formula, v equal to W by Q. So here we go. So work done is nothing, just an energy, so half mv square. It is the initial kinetic energy, and we know that the what is v is equal to kq by r. Okay, so here is r approach, so we can write it k is what, 1 by 4 pi absolute naught. Okay, and while writing as q, we know that the q is ZE, so we'll write the ZE by r, distance of closest approach. This is the distance of closest approach, into this charge is the alpha for helium. Okay, for the helium particle. Okay, so helium is nothing, just it is it charge has 2e, so we will write the helium charge. Okay, and after that we can say that this is nothing, just a kinetic energy, and this is 2Z E square by 4 pi absolute naught R naught. So from here we can say that the R is proportional to the 1 by KE. Okay, so this is that's it, and here we can also write it as 2ZE by 4 pi absolute naught KE. So this is the distance of the closest approach. Okay, and this is the relation between distance of closest approach and kinetic energy. So thank you.